I'm going to talk to you a minute about log equations. So I'm going to go through a couple different scenarios for you. The first one I want to talk about is when you just have one log expression. So this is one of the easier to do. One log expression would mean something like log base 2 of x equals 5. So what you want to do is you want it just like with the exponential equations, you want to make sure that that log is isolated before you start, okay? And if it's not, get it isolated. In this case it is. And then all you have to do is change forms. And generally when you do this, the answer will kind of pop out at you, or you'll see exactly how to get to the answer. So in this case, the base is 2. Remember, logs are exponents, so the exponent is 5 equals x, and of course 2 to the 5th power is 32, which means x is 32. So an easy solve if you only have one log expression. Let's say, however, that you have two log expressions, but those two log expressions are all you have, and they're set equal to each other, or you can get them set equal to each other. So set equal. So for example, maybe I have log base 3 of x plus 1 equals log base 3 of, we'll even make it a little bit harder, x squared. Well, because there's nothing else with this, I only have two log expressions, and these log expressions are equal to each other, then I can set these arguments equal and kind of disregard the logs. And I can do this because if I were to use exponents and things like that, I would have some nice cancellation going on, and we won't get into all that. We'll really focus on the fact that we can just set these two equal. Now I have a quadratic, so of course I'm going to make my quadratic equal 0. So subtract x and subtract 1. So ideally here I would try to factor this, and of course, as we all know, this one is not factorable, so the only way that I'm going to be able to solve this is to plug into the quadratic formula here. So I would do opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a, and I won't spend, well, let me plug in my a value here. I won't spend a lot of time going through simplifying this. I'll just kind of work quickly through here just so you get the idea. 1 minus 4 times 1 times negative 1 is negative 4, so that would give me a 5 under the radical divided by 2. Nothing really simplifies here, so this is my solution. So two log expressions that are set equal to each other, not such a bad deal either. Then I have a third scenario. And in this scenario, I'm going to say that I have 2 or more, greater than or equal to 2 log expressions. So this time, maybe I do have 2, but maybe they can't be set equal to each other because there's some more things going on in here. So I'm going to say something like log base 2 of x plus 2 of x minus 2 equals 3. So what you want to do when you find yourself with a situation like this is you want to condense all you can. And if you remember back, that's using those log properties. We want to condense until we only have one log, because then we can go back to that scenario number 1 and we can use that to actually solve. So I want to condense until I get down to one log. So if I look here on the left side, I can condense these two. The addition tells me whenever I condense them to multiply, so I'm going to have log base 2 of x times x minus 2, and all these go, this whole thing goes with the log, equals 3. So now I have log base 2. I'm going to distribute this x through, remembering that this is still kind of connected to this log here. It's the argument of the log. And so now what I want to do, I'm back to that scenario number 1 where I only have one log. And so I can proceed with scenario 1. So I'm going to say C scenario 1, which means change the form. The base is 2, logs equal exponents, and the argument is x squared minus 2x. Again, I have a quadratic. 2 to the third is 8. So I want to make it equal 0. I can move that 8 on over. I'm going to come right over here. So I have 0 equals x squared minus 2x minus 8. And I hope at this point we can all factor that easy peasy. That factors as x minus 4 times x plus 2. And remember, the nice thing about factoring like this is because I can set each piece now, since they're multiplied together, to equal 0, I can set each one to 0. And I can solve. So add a 4 to both sides. Here's one solution. And subtract a 2. Here is another solution. So again, it's about getting it down to a scenario that I can work easily with, using those log properties to condense.